Hey, Vlad here, DependencyGraph.com. Welcome to another video. Today we're finally going to see our Tagless final to-do app in action. We're also going to start the conversation about concurrency, talk about Cat's effect graph, and start using Cat's effect, monix, and Zio all in the same app. Let's get right to it. In the previous couple of videos, we converted the core, the delivery, and the persistence layers. All that is left to do is to go into the main and fix the dependency graph. So if we go to the main, go to source, go to corrupt, there's a dependency graph. So we're going to do the same trick as we always do. Go over here, F2, dependency graph, hold, save all the files. Let me open the terminal. Everything is still fine. Copy the file, rename it to dependency graph. All right, so let's close all the others. This one is going to be called dependency graph now, like this. So let's go ahead and add our F over here. It's going to be F like this, and it's going to need a sync because all of the other guys want the sync. Okay, so everywhere where we say old, let me do this. Let me just do that. All right. We probably don't need this F. We probably don't need this F, and let's see if that works. You just need to say effect.sync and import cats. Import cats. Also, let's have a little bit more space like this. Let's see if it's happy now. Object variant does not take. Okay, so this was too much of F, right? So this F like usually would be here, right? But we don't need it. Okay, like this. And there we go, it compiles. Now, I have one issue with this, and it is the fact that if you remove these guys, everything's still going to compile, right? And this is happening because if you go to something, so what did we have before? We had the fancy console and we had the random, right? So if I go to something like random, we're going to see that in the companion object, I made this method implicit. And I told you a couple of videos ago that I usually do this like when it's possible, then I mark them implicit, but it doesn't mean that I use them implicitly. Now I'm kind of looking at this. Well, technically, during the preparation for this video, I looked at this and I was not happy with it. And I actually remembered that in that book that I mentioned a couple of videos ago, from Gabriel Volpe, is that you can actually differentiate between type classes and DSLs, right? So they all look kind of similar because it's just a trait and there's a parameter f, but you can actually differentiate them. And the way you differentiate between them is that you kind of take the Haskell approach where you talk about typeless cohesion, where you basically say it's not a type class if it has multiple instances, right? It's not really a Scala view because in the Scala ecosystem, you can kind of have like for example we're using ordering as a type class, even though you can have like two instances of ordering, right, ascending and descending, right? But if you want to take like this clean approach, this clean view on type classes, then you would say everything that is a type class has only one instance, and therefore we're gonna use all the type classes implicitly, right? So we're gonna use them as context bound like this, okay? And everything that can have like multiple implementations, for example, our entity gateway, in a test is gonna have one implementation, and in production it's gonna have a different implementation. All of them we're going to inject explicitly, and therefore what we're gonna do is we're gonna go and we're going to remove all of these implicits. All right, so if I do that, then it shouldn't be able to find it over there exactly in the dependency graph. So now I'm kind of forced to go into the dependency graph, and I'm forced to do something like, okay, I also want the random, right? I could still, put it over here as a context bound, but we just discussed it that we don't want to do that. Okay, so I'm just going to say, hey, I want to have the random of f, and therefore into the boundary, I'm sorry, into the controller that needs this random, I would need to go to the controller, and I'm going to do the same thing. I'm going to remove the random. So we need to do like a little bit of refactoring. Okay, so I'm going to say we're going to also need the random, and we're also going to need the fancy, let's just call it console. Console, which is going to be a fancy console of f, comma over here. Maybe let's bring the pattern up like this. It's going to look nice. A pattern and then everything else. All right, now everything in here is not going to compile now. Actually, let me open the minimap. Okay, so this way we should see a bunch of red stuff. Why don't we see a bunch of red stuff? 251. Okay, did I mess something up with the parens? DSL, opening here, closing here, comma, comma, and there's no comma over here. All right. What's up with bloop? Where are my error messages? Hold up, let me do this real quick. Start SPT again. All right. Because like everywhere where we use, like, for example, this app.nextInt, it shouldn't compile anymore, right? Because we said that we want to pass the random int explicitly. Okay, so this should be underlined rad, and it should tell us that f does not have the method called nextInt anymore. Right? Yeah, there we go. All right, so this is going to be the random like this. So this should work now. Let's also go over here. Let's go to the main. Let's start compiling the whole thing. Let's go over here. Okay, so now pretty much everything that is left, it should be the console. All right, over here. Yeah. All right, so we're just gonna say console. Okay, so it should be enough for here, right? So everything, like all of this red stuff, should go away now. All right, what else is left to do? Okay, so if we go into dependency graph, which is over here, now it's going to say that we need to pass in the random and we need to pass in the console. So we have the boundary. We're going to say console equals something and random equals random. Okay, so now let's go and fix the console. Let's go to fancy console over here. Let's also not make it implicit. The same thing with the console, you know, there might be different implementations, so we need to remove that. Say that we need a console over here, console of f. Therefore, everywhere where we say f dot, we're just going to say console like this. Let's also go to console and do the same thing. There we go. It's not going to be an implicit def. It's just going to be a regular def like this. Okay, let's scroll down. And this is all that we needed to do. So now over here, we're going to simply construct a fancy console by giving it the console that comes from here. Console, which is the console of f, like this, right? What's up with here? Does not take type parameters. Come down inside the fancy console .dsl. There we go. Okay, so this is like this tiny refactoring, and now we kind of see the entire dependency graph over here. Cool, so we're finally ready to start writing the main, and we would finally need to specify what f means. And for this, we're going to use cats effect IO. And as a reminder, as of right now, we don't have the real cats on the class path, so we're going to go and implement our own version of IO, and it's going to have an instance of sync. So let's go and do this. So let me collapse all of this. Let's go to cats effect source. So we have cats effect sync, and we're going to go and say new file io.scala like this. All right, so we're going to do package cats package effect. All right, now if you have seen my videos from my previous videos, we have implemented IO in so many ways, and today we're going to go with SAM types, single abstract method types. So we're going to have a trade IO. It's going to have only one function, unsafe run sync. All right, so we're going to say trade IO, and it wants some A. All right, and it's going to have unsafe run sync like this. All right, nice, cool. Now we're going to have an object IO, right? So this is going to be like a typical type class, right? So it's going to have only one instance, and therefore inside of the object we're going to have an implicit val and DSL. It's going to be sync of IO equals new sync for IO like this, and let's allow Metal to generate everything for us. Implement all members. Let's do this, remove this one, remove this one. Pure is always the constructor, so I always prefer to move pure up like this. All right, cool. Now, again, this is a single abstract method type, and therefore, in order to implement this, we don't need to go over here and say, new IO. We can just go and start with the lambda that matches this signature, right? So basically, unit comes in, A comes out. Okay, so unit comes in. All we need to do is to produce an A, which is like this. Okay, so if it's a pure expression, we just stick into a thunk, and it's already evaluated. Okay, now let me rearrange a couple of things. Let me move defer up. Okay, let me move defer. Okay, so defer is kind of very, very, very similar. So we're going to go over here. So all of them are going to start like this, right? So everything is going to be like this. Okay, cool. So all we need to do is we need to take the f of A, and we need to do unsafe run sync. Okay, so we basically need to like run it once, right? But we're not running it, we're just constructing a thunk that would run it. Okay, now as a reminder, if we go to sync, okay, we're going to see that it implements delay for us. Okay, and it implements delay in terms of defer and pure. However, IO is pretty much designed for delaying things. So we can actually override this and do this in one single operation. So we can go over here and we can say override, and maybe metals can help me. Yes, override delay like this. And we're just going to do this arrow to the right like that. And we're just going to do A. Right? So this is pretty much already delayed, right? So compare pure and delay, the same as we discussed in the previous videos. They're pretty much the same. It's just that A is not evaluated yet. So all we're doing is we're wrapping it into a proper thunk, and it stays not evaluated until somebody calls unsafe run sync. All right, cool. So yeah, a product. Let's rearrange them again. So this is going to be functor, right? So this is going to be map. Okay. So again, everything starts with a function like this, arrow to the right. Okay, so and as always, like what can we do? Well, we can grab an A by doing fa dot unsafe run sync. Okay, now that we have an A, we can grab the B by applying it to the function, and we're done. Okay, so this is the typical map. Now let's do product. Maybe we should do flat map first. Yeah, let's do flat map first, because flat map is going to be very, very similar. In fact, I can copy this. I can go over here. I can paste that in. Okay. So now if we do an FA unsafe run sync, what we're getting out is still an A, but when we're sticking it into the next function, which is called AB, it should be called A to F of B. Let's rename it over here. Let me not forget to rename it over there. Okay, so A F of B. Okay, so now this is an F of B. Okay, F of B. Okay, so we now need to go and to actually get out the B by running it again, right? And now we have the B out, and we're pretty much done. F of B like this. Okay, let me actually go to come on, jump in there. Sync monad flat map. Yeah, I want to call this one A to F of B. Okay, like this. Cool. Let's go back to sync, not to sync to IO. Let's go over here. So the only thing that is left is product, and product is an interesting one. So remember, IO and like sync is all about like monads are all about doing things sequentially. Okay, but over here we kind of have a choice, right? So we can we can grab the A, right, by doing FA unsafe run sync. We can grab out the B by doing F of B unsafe run sync, right? But if we were, we kind of have like an opportunity. Why do I keep spelling DB? All right, we kind of have the opportunity here to to ruin a couple of things and do this, right? It's still going to compile, okay? But it's sort of like your job to write like the property based test to check the monadic clause, to check that the product behaves the same as as the monad specifies it, right? So it needs to be sequential. So you have to do the FA first. All right, and there we go. Like this is the entire IO. This is the entire implementation of the sync instance. And now we can actually go and write our main. So let me go over here. This is going to be our main source. What's wrong with my voice? I just started talking. All right, so let's go to the main. Hold on, main over here. We can pretty much manually rename it. It's going to be main old, and I'm going to do this because we're not going to run it anymore like this. Okay, so copy paste, and this is going to be the new main like this. Oh yeah, because I didn't use F2, we didn't actually rename it. Okay, so let's do main old, and this one is going to be called main, and we're just going to do main like this. And now it's going to extend the app like this. All right, so we're still constructing like the the old controller, but now we're going to construct the new controller. Okay, so now finally we can have just an alias for our app. It's going to be an alias for effect IO of A. Okay, let's go and import cats like this. All right, so now our app is fixed. It's fixed to IO. So we can go and we can construct a controller. So it's not going to be controller old anymore. It's going to be a controller of app like this. So we're going to go dependency graph old. It's going to be a DSL of F. Well, actually don't need to specify the F over here. Okay, so just as a reminder, just right now we were doing everything explicitly. So we need to pass in the pattern, the console, and the random. Okay, so we already have the pattern. We need to grab the console console.dsl, and the random.dsl like this. Let's create more space like this. In fact, let's actually grab this pattern, and it's going to be a constant. So let's just do pattern like this. Put it over here. Pattern equals that thing. All right. Maybe even like that. I know that looks ugly. Okay, like this. All right, cool. So now it says controller run does not take any parameters. Okay, like this. In fact, let's actually go and rename run to program. Okay, I forgot to do the dependency graph over here, like this. All right, let's actually go to run because as of right now, it doesn't actually return unit, right? So this this is essentially a program which returns an f of unit. Okay, so maybe we should go and rename it to program. Maybe I can do it from here. Let's see, program, and it looks like it did it. Yep, it did. Okay, cool. Now, almost, almost. Okay, program. Wow, look at this wall of red. Let's go to main. Let's actually close all of the others. All right, cool. So now this is a program, and now we're going to have like the hand wavy way to figure out if we did everything correctly. So I'm just going to do a print line. And I'm going to say, until now, everything that we were doing, we were just constructing a program. So nothing was supposed to be running. So what I'm going to do over here is I'm going to say scala.console.yellow, and let's not forget to do this. Okay, so just like as a warning. Okay, so it's going to be warn. And then I'm going to do scala.console.reset. I'm saying scala dot because we have our own version of a console. Okay, so and now we're going to say any output. By the way, I'm doing like these brackets because I want to make it look like this. Okay, so it's going to be any output before this line is a bug. All right, so so now if we were to actually run this program, okay, we should not see anything. Okay, we should see like only this line and nothing else before that, right? Because everything that happened until now was just constructing a program. Okay, so it says running, and then it says any output before this line is a bug, right? And we didn't see anything before this line, which is cool. Actually, we do have a sort of like a not ideal thing, and we're going to talk about this by the end of this video. And by the way, this video has a tendency to get like very, very long, and I might actually split it into two. All right. Anyway, we're actually finally ready to do program unsafe run sync, which finally returns a unit, which finally does exactly what we want. And there we go, our first tagless final program. Show all, doesn't show anything. Create by milk. It's going to be 220. It's going to be July, and today is actually the 4th of July. Who would have thought? And we have 10:59, so let's do 10:59. Show all. Everything kind of works except for one teeny tiny little thing that I kind of knew about. If we try to delete one of the to-dos, so I'm going to say where is it? So this is delete all, delete to-do, just D. Okay, it's going to throw an exception, and I kind of know it because I prepared for this video. So if we go to the controller, if you go over here, it's going to say, okay, the stack trace is actually kind of useless. All right, so, but basically we know that it was triggered when we press delete. Okay, so if we go to the controller, and if we go to delete, we're going to see that it's a val. Okay, and we're going to see that it uses, with ID prompt, which is below, but with ID prompt uses ID prompt, which is above over here. Okay, right? So basically, this val needs this val. Okay, so you kind of have like this typical density you have with the val. So you can either make a lazy val, or you can just be nice and move it up. Okay, like this. This is all we need to do. This has nothing to do with tagless final. This just has something to do with the way the vals are handled. And I believe in Scala 3, there might be a slight improvement in terms of error handling. So it might be able to, the compiler might be able to detect these things and warn you. Okay, so now if we do delete, it doesn't throw an exception, right? So it wants the ID, so we can type something in. Okay, now. When I'm going to play too much with this app, just believe me that it works because I prepared for this video. Okay, you can actually, clone this repo and play with it yourself. But we're far away from done from this video, in this video. Okay, so the next thing that we're going to do is we're going to look at this main, which is not here. We're going to look at this main, and we're going to refactor it a little bit, right? So we're going to take because over here, we kind of have already the dependency graph, but we have the dependency graph only for this one use case, which is CRUD. Okay, so I want to refactor this part so that we also have a dependency graph which assembles the entire program, which in our case is just like one use case, so it's not like super exciting, but still. So I'm gonna go and I'm just gonna create a new file. I'm gonna call it program.scala. Okay, it's gonna be cats dev inside. Why did I say cats? Com dev inside to do. Okay, so it's gonna be object program like this. Okay, so we're basically going to have we're going to construct a program like this, right? So it's going to be an f. It wants the effect sync, and it's going to produce an f of unit. Okay, like this. Okay, it's going to be equals, and now I'm going to go to main, and I'm going to paste pretty much all of this stuff, right? So this is what I want. Okay, so I'm just going to paste it over here. I'm going to take the pattern out, and I'm going to put it under the DSL. Okay, in fact, I can actually make it private. Okay, private. Okay, so we're constructing the crowd controller. We have the program. We have the, where's the print line? We have the print line over here, and then we're just going to return the program, right? Which is going to be an f of unit. Okay, so let me create more space. We probably need a bunch of imports. Okay, so let's see. We need import cats. Okay, we need this guy, which is over here. By the way, recently a new version of Metals came out, and it finally does this thing right. So usually before it was putting this import over here and breaking everything. All right, so now this is what we have. So if we go to main, we can now pretty much say that we're gonna pretty much throw everything out. Yeah, pretty much everything. Okay, we're gonna throw it out, and we're just going to say that we're constructing a program DSL, and we're gonna say that it's gonna be cats effect IO, and we're just gonna do unsafe run sync like this. In fact, we actually don't need any imports anymore, right? This is exactly why we did it, right? So that over here you just specify your app, and that's it. This is the only thing that you're doing, and this is now a very clean main, and everything still works exactly the same as before. All right, let's switch back to compiling. Cool. So as I mentioned a couple of videos ago, because we're implementing our I/O ourselves, we're only implementing it good enough for an educational video. I told you that it is not stack safe. Okay, so we're going to demonstrate this now. So if you go to the controller, remember our main loop in run, right? So it's going to do iterate while, and it's going to do this continuously until it builds up all the stack and until it explodes. So what we're going to do is we're going to go to SBT opt, which is over here, which is a file where you can specify a couple of parameters for SBT, and we're going to add one, which is going to be XSS227K. All right, and now if we reload SBT, it should explode. Well, actually, maybe we actually need to quit SBT and start again. It should explode because it's going to say that the least amount of of the size for the stack is 228, which is exactly why I put 227 in there. Okay, so let's actually go start it. All right, and what we're going to do is we're going to run the main, and then I'm going to put my fingers on enter, and we're just going to wait until it explodes. In the preparation for this video, it took around 45 seconds. All right, so we're just going to say run. Okay, so I'm going to put my finger on enter, and we're just going to wait until it explodes. And there we go. All right, yeah, so it's still pressing enter, and there we go. We have our Stack Overflow it's a bunch of flat maps, never-ending flat maps. Now, at this point, we can actually, throw out our implementation and replace it with, with the proper cats. But I want this video to be about ref mostly. So we're going to go and implement ref ourselves before we replace everything with cats effect. And let me actually go out. Let's go back in. Okay, and before we do that, we're going to make a ton of improvements to our in-memory entity gateway. Okay, so we actually go there right now. In-memory entity gateway, right? So as a reminder, the initial version of this app I wrote like 2 years ago, it has like these vars, it has like concurrency issues, which we technically don't have now because as of right now, we only have the terminal interface, and so we're, there's only, we're the only person we're the only people who can access the same memory. So technically, we shouldn't need to worry about concurrency issues. However, a couple of videos from now, we're going to have a proper database, we're going to have a proper web server, and over there, it's going to become important. So we're going to improve all of this stuff, introduce ref, which is going to allow us atomic access to these vars, and then we're going to throw out our implementation of cats and cats effect and use the proper one. Okay, let's actually just compile the whole thing. Doesn't really matter. All right, so let me bring this down a little bit like this so that we can take a look at this again. So this thing, it basically generates IDs by just doing +1 in create, right? So it's just doing +1, and then it just puts the to-dos into the vector. And if you think about it, the size of the vector can actually sort of like generate a new ID for us. So technically we don't need this var. So if I were to just throw it out, well, actually I'm just going to comment it out like this, then only this part is not going to compile, but over here we can say state.size. Okay, and that's pretty much it. We can just throw this out and it's still going to work exactly as it worked before. In fact, let's have a teeny tiny demonstration. Let's go to cd main again and let's run it. Okay, so we're going to do by milk 227.4, it's 1108. Okay, let's create one more by even more milk. All right, same thing, 7, let's do 5, let's do 1108, show all, a little bit more space, and there we go, right? So the IDs were still generated, right? So the IDs are like the size of the vector. So we're kind of like improving things. So now we have like at least one var to worry about instead of 2. Okay, let's switch back to compiling. Let's go down. All right, now it's kind of cool, but now we kind of got rid of the notion of next ID, so I kind of want to bring it back. So if I actually go back over here, I'm going to put it down and I'm going to say that this is a daf. Then I'm going to say that it's just state.size. Okay, now because it's a daf, it's not referentially transparent. Okay, so it's still going to work exactly the same as before, right? So next, what do we call it? Next ID. Okay. Next ID. Okay, so now this part didn't change. So we just kind of like change the var to a def, put a state.size in there, and remove the increment. Okay. Now the problem again, like this is not really referentially transparent. So in a Tagless final or in functional databases, code bases in general, we don't really like methods like this, right? So they break the entire model of substitution, and kittens die. All right. So what we're going to do instead is we're just going to put it into an f. So simple. So we're just going to put it into a val. We're going to say that this is going to be an f event, okay? And therefore, all we need to do is we just need to delay this thing, okay? Delay, okay? And therefore, we can go over here. We can say that we're just going to grab the next ID over here. We can just flat map it like this. So this is going to be the ID now. Let's close this brace over there, and this is going to be id.toString. Okay, so it should behave exactly the same as before. Okay, but now that we have this, it actually gave us a lot of improvements for a lot of opportunity for improvements, right? Because now we can have combinators and all of these things. So for example, now we don't need to delay the creation of this val, okay? Because before we were calling next ID over here, right? And it was like not referentially transparent, so we had to delay that. But we already have a delay that is happening inside of the next ID, so we actually don't need to do this. So what we can do is we can go over here. And the first thing that we're going to do is we're going to do ID arrow to the right, and over here we're going to say todo.existing, and this is going to be the id.toString, and this is going to be the to-do, right, which is the data. Okay, so now when we're doing flat map, we're actually already dealing with this created thing. Okay, so we can just throw it out. like this, right? So we still need to delay the fact that we're adding it to the adding it to the vector, but at least now it's outside, and because it's outside, we can actually throw out this one, right? So we can just do this, and we can just say as created, okay? And then we can actually inline that one like this, and do something like this, or maybe even something like that, right? So our code got like a lot of shorter because now we're capable of like composing things together, as you always hear from like functional code bases. Okay, so this is a very powerful technique, and a very safe technique. In fact, we could even continue going with this, and we could say that we would move this toString into the ID over here, right? So we can just do size.toString. So this is going to be a string right away. Therefore, we don't need to do ID.toString, and therefore maybe Scala will even allow us to just have an underscore over here, right? So our code is just like melting and melting and melting. Now, the next thing that we're going to do is going to be a bit of a stylistic change. So in the upcoming videos, we're going to have a notion of a database, like an actual database. And over there, we're going to have sort of like a bucket of database statements, right? A bucket of queries, a bucket of commands. And, the complexity of my videos are going to, of the videos in this playlist is going to increase more and more. And so I want to sort of prepare in such a way that that whatever implementation we have right now is going to look very similar to what we're going to have in the future. So what I want to do is I want to take like the majority of this code base out, and I want to put it into another DSL. It's going to be called statement. And what we're going to do over here is we're just going to say, something like val statement, which is going to be a statement of f, and it's going to be like statement dot DSL of f, and we're going to give it like whatever it needs. And over here, we're just going to call the statements, right? So one of the goals over here is going to be to move the sync out as much as possible, right? So because again, like sync basically says that you can do whatever the hell you want over here, but we don't want that. So similarly to how, if we look into the controller, we moved the sync out of here, right? So it just needs a monad. All the syncs are inside of the fancy console and inside of random, okay? But when you're writing your tests, for example, you can stick the fake implementations of the fancy console and of random, and they might not use sync, okay? So you just move it out completely. In fact, since this video is going to be very long, I'm thinking that I'm just going to copy paste this statement thing from my script. It's going to look very similar to this, and we're going to go through it in just a second. Okay, so I'm basically going to create a file. I'm going to call it statement.scala. Okay, it's going to take everything and paste it in. Let's see if it actually compiles. It does. All right. So if you look at statement now, it looks very similar to our in-memory gateway. Okay, so it basically has, okay, so there's going to be a state, which is going to be a vector empty. There's going to be select all, right? So this is going to be like the DSL, right? It's going to feel like a database query kind of thing, right? So you can do insert one, update one, select all, delete many, delete all. Okay. So you have like select all, just going to delay the state, right? So I'm basically making sure that everything in here uses delay, or to be more specific, sync, right? So I'm creating an abstraction that is like really needs sync. And yeah, so next ID, same as before, insert one, look, it looks like literally exactly what we had, what we just had right now. Okay, if we go into the in-memory gateway, yeah, it looks exactly like it did before. Okay, so update one, all the same, delete many. It just does like exactly what it was doing before. Okay, delete all, delay. Okay, cool. So now we're going to go into the in-memory gateway, and we're going to basically say that it's going to have the statement. Okay, statement of f equals statement.dsl. And what does it need? I think right now it doesn't actually need anything. Okay, yeah, right now it doesn't need anything. Okay, it's just going to be statement.dsl. Okay, and then we will be able to use this statement over here. So right now we can pretty much throw out the state, throw out the next ID. They're all accessible through this statement. Let's look at write many. So it just does to do traverse, write one, and write one just pattern matches and does like create one and update one. Okay, so we can actually throw out all of this out because like the statement is doing all of this for us. So we can just go to write many over here and say to do traverse, throw this out, put this pattern match in there like this. Okay, let's actually rename this one to this is going to be an insert, and this is going to be an update. Okay, so right now it calls a create one and update one. We can throw this one out. Okay, we're going to do the same thing with statement, right? So we're going to do statement dot insert one and statement dot update one. Okay, and I believe I spelled it wrong. Okay, like this. Okay, so we basically don't need like these private defs. Like this is exactly what I meant, right? We're still going to have like a little bit of logic over here, right? But the actual like databasey stuff is going to be inside of statement, okay? And you're going to see why we're doing this in just a couple of seconds, well, probably minutes, and also in the upcoming videos where we're going to create an actual database, okay? So read many by ID. So for example, see like it does like, you know, the whole delay. Instead of this whole delay, we're just going to go to statement and it's going to do the delay for us, okay? So we're just going to do select all, and then we're going to map it, right? And inside of the map, we're going to have like the same filter essentially, right? So we can do right. So the statement, it in this particular case, it allows us to have access to state, right? So this thing is going to be okay. Well, blue probably doesn't show me it correctly. Okay, so we're just going to have that. Okay. All right. So this is insert and this is update. Update like this. Okay. Cool. So as you can see, it compiles. So which means that I can go in over here, say that, yeah. So this is the state, which is the vector. Okay. Cool. So read many by partial description, the same thing. So we're not going to delay anything ourselves because we don't have access to the state. And in order to get access to the state, we need to go and talk to the statement. Okay. So statement. By the way, it's a coincidence that statement and state. You know. All right. So select all, same as before, and now we're going to do map. Okay, and inside of it we're going to have, you know, access to our state, and inside of it we're going to do the same as we were doing before, which is this. Okay, like that. And in fact, in this particular case, we can actually have an underscore over here like this. Throw this out like that. And where do you come from? Filter like that. There should be dot over here. And there we go. Okay, so through the statement, we're getting access to the state, and we're doing this this tiny dance. Okay, now all the others are kind of boring, right? Because like over here, we're just like delaying to the state, and I did it in such a way that we just need to delegate. Select all, and I know that this is going like a little bit too fast, but it's just a refactoring. Okay, so I kind of don't want to waste too much time on it. Okay, so like usually I would do this like between the videos, but in this particular case, it's actually necessary to derive the graph. Okay, so statement delete all. Okay, and I believe this is it. Okay, let's go real quick. We don't have proper tests. Okay, so as of right now, I'm always going like to a run, and I'm just doing show all, and I'm like, okay, nothing is exploding. So for now, it's good enough. Okay, so let's bring it down again. All right, so I just checked. I've been recording for 45 minutes. So once I cut it, it's gonna be like half an hour. So maybe it's actually a good place to break this video apart. So what we're gonna do, I'm actually gonna open the console over here, and I'm gonna see how we were constructing our messages. Okay, so what I'm going to do is I'm gonna commit right now, and then we're going to continue writing the rest of the video. Okay, so let's do gcam, and it's going to be video video 9. Video 9. That's going to be part 8. I'm thinking whether I should do like video 9.1. Now I'm going to do this, video 9, part 8. And by the way, if you're sort of paying attention to this change set over here, until the video is released, I'm sometimes rebasing the change set, right? But then as soon as the video gets released, I'm going to have a link to the exact change set in the description of the video. So don't pay too much attention to this particular hash set number, okay? So let's see, video 9, part 8. Yeah, it kind of makes sense.